Hi all, and welcome to my implementation of the program counter for task 5.2. So what I've got here is my implementation. So as you can see, we have the inputs of the data, the 16-bit sort of word that's being input, the load selection bit, the increment selection bit or control bit, if you want to call it that, and then we have the reset control bit, and then we have the 16-bit output. Now, how I got to this code was I drew a diagram and worked my way through it with the constraints. One of those constraints, or the three constraints pretty much, are that reset takes precedence over a jump, and the jump takes precedence over an incremented value. So what I came up with was any input that goes into the program counter, we are going to increment it immediately. And then that incremented value is going to be fed into our first multiplexer, of which we have 3. So our first multiplexer is going to take an incremented value of the input and a non-incremented value of the input. So hypothetically, if the non-incremented value is 100, we're going to give this first multiplexer 100 and 101. And then depending on the INC, or the inc control bit, if that's set to 1, then the incremented value goes through. If it's not, then just the normal bit goes through. Then we're going to feed the incremental and non-incremented bit into our jump multiplexer, which is going to contain the input and the incremented or non-incremented bit. Then we're going to choose that dependent on the load control bit. And that kind of does make sense as well, because if the program counter has to jump into a program, we want to jump to the input, because we're going to be taking that from the A register. So then we have our either incremented or our jump output that is going to be fed into our last multiplexer, which is we can think of it as our reset multiplexer. And we have the incremented or jump value, and the second input is going to be just false, which is all zeros. And that what we choose is dependent on the reset control bit, and we put that output into our register. We always have load as true. We then put the out feedback, which is going to be a loop that just goes back into the incrementer, which is how we get our values to increment no matter what. And then we've got our output here as well, which will probably go into the instruction memory input sort of register, and away it goes. But basically, this is everything you need to have the program counter functioning correctly. So I have the hardware simulator here. I've put that exact code that I just showed you into this. I've got the test file loaded. I've got everything set to fast, and I will run it now. So as you can see, the script tested everything, and the comparison ended successfully, which means that everything is working as it should. And it does make logical sense when you step through the code for why it works the way it does with different use cases. So if you need an increment, if you need a reset, or you need a jump, running through it makes logical sense. And that's it. Thanks for watching my video.